Hello, guys, welcome back to the second lecture of this series, which is data preparation. Why data preparation matters? Because it ensures our machine learning models will function correctly and produce accurate results. The key stages of preparation is data collection. Gathering data from various sources such as databases, spreadsheets, web scraping, etc. The second is data cleaning, which includes handling missing values. Techniques include like imputation, filling in missing values, or removing rows, columns with missing data. The second is removing duplicate values to ensure that each data in our table or data point is unique. The third is correcting errors, like fixing typos and inaccuracies in the data, which ensures that we will not again improvise data. The third is data transformation, normalization, and standardization. The fourth is data integration, combining data from different sources to create a unified data set. The fifth is data reduction, in which two steps are included, which is feature selection, like choosing the most relevant feature for the analysis, which sets our data, which is good for our data. The second is dimensionality reduction, techniques like PCA, which is principal component analysis, to reduce the number of variables, and data splitting is the last step, which is dividing the data set into training and testing sets to evaluate model performance. Now, for example, the first topic is how to add an index field using Python. An index field is a unique identifier for each row in your dataset. While Pandas automatically assigns an index, you can also add your own index column explicitly. In this example, we can see that first line is import pandas. We are importing the panda library as PD. As I have told you in the previous lecture, AS keyword is used to, like, we don't want to write pandas every time we want to use its function. So we import it as PD for our efficiency and for speed. Now make a variable data in which we'll add our dictionary name Alice, Bob, Charlie, and their age is 25, 30, and 35. Now we'll take a variable df where we'll import a function of our pandas, which is pd.dataframe data. In this, see that we have written data inside the bracket so that our dictionary will be imported as the data. Now adding a custom index field. Df index is equal to range. Now here we are giving the range for our index, like 1, then comma, length of the df plus 1. Print data with index field. This operation of range will print the data with index. Um, Length of a function gives the maximum output, here the length of the function is 2. So no, here the length of the function is 3, but in the range we want to write 1 plus, so we write length plus 1. Now changing misleading field values using Python. The first is identify inconsistent values. Review your data for inconsistencies such as typos, incorrect data types, or misaligned values. Second is replace inconsistent values. Use Python strings manipulation functions to replace incorrect values with the correct ones. The third is validate changes. Verify the changes made by checking the data again to ensure accuracy and consistency. Example is df age is equal to df age dot replace 3536. Here we are replacing 35 with 36. So the all the data that is 35 will now be changed to 36. Now we'll print the data. The next is re-expressing categorical field values using Python. Label encoding, one hot encoding, and target encoding. In label encoding, we convert categorical values into numerical values. In one hot encoding, we create a binary representation like in 0 and 1 form of categorical variable. In target encoding, we replace categorical values with the average of the target variable. Example now here, see DF status. In status, we are including like single, married, and married. Like, what is the status of their relationship? Now, status code. DF status dot map now will map single to one, married to two. Like, single is mapped to the one, and married is mapped to two. Now we'll print it. Now, the next is standardizing numeric fields using Python. It ensures that all numeric fields have a similar scale, making it easier for machine learning algorithms to analyze the data. Common techniques include minimum maximum scaling, Z score, and robust scaling. Select the method that best suits your data and specific needs of your model. Every data needs another type of algorithm for it, so it's better to go with that which you know well. Now, in this example, see, we are importing standard scalar. Now, scalar equal to standard scalar df. We have in previous examples created a df variable in which we are storing the data. Scalar dot fit underscore transform dfh. Now we'll printing the standardizing numerical fields which we have changed. Now the last is identifying outliers using Python. Outliers are like values which are not suitable for our database. It might be true or it will seem true, but it will create problem. So the first is identify potential outliers. Examine the data for values that deviate significantly from the general trend. The second is investigate outliers, determine the cause of outliers and decide whether to remove them or adjust them. Handle outliers, apply appropriate techniques to handle outliers such as capping, replacement, or removal. Now, after running the full script, you'll have a data frame like this. See, we have